All right, so today we're going to look at one additional type of factoring, and then we're going to do synthetic division again for the last two examples. But looking at example 4, before we get started on either one of these, I want to do an extra example here, because I think it'll kind of help us understand it a little bit better. Let's say I had a question that said x to the 4th power plus x squared minus 30. How would I factor this? But do I have a greatest common factor between all three of them?
No.
No, so I can't take out a GCF.
Except for -1. But that wouldn't really do anything.
Yeah. -1 wouldn't really help us because then that would make our leading coefficient negative, which we really wouldn't like.
So we separate them into 2 different groups.
We could group, but there's an easier way. What would multiplying the first and the last help us do?
It would just help us break it out. So you do -30 x to the 4th, and then you just whatever equals
Bro, isn't that just x to the 6th power?
No, we can't add them together. They're not like terms. Because they have different exponents. No, we wouldn't divide it. So it's actually easier than what we're thinking. So we need to think, what are 2 factors of -30 that add to 1? 6 and -5. So in my parentheses, I do the same thing I did before. I'm going to put a +6 and a -5. But what do you think is going to go in the first spot now? Both of them get x to the 4th powers? X squared. So it'd be x squared and x squared. Because if I break this down, it'd be x squared times x squared. So it's the same thing as factoring normally if this was an x squared plus x minus 30. But instead we get an x in both of them. So it'd be x plus 6, x minus 5. But instead of breaking it down into x and x, we're breaking it apart into x squared and x squared. If you FOIL this back out, you would get the original question. All right, so let's look at example A. What do we notice that's special about 16x to the 4th power and 81? They're both perfect squares, so this is the difference of squares. Remember, the difference of squares factors into a plus and a minus. So what are my 2 factors that 16x to the 4th power breaks down into? What times what? The same number gives me 16x to the 4th. 4x squared, perfect, and 4x squared. Because we have to break that x to the 4th power apart. And then what are my 2 factors of 81? 9 and 9. So in my parentheses here, I would put 4x squared plus 9 and 4x squared minus 9. Now we always need to check. Can this be factored anymore? How? Which one? The right one. Because the right one, again, is the difference of squares. 4x squared is a perfect square, and 9 is a perfect square. Could I factor the left one? No, because it's not the difference of squares we're adding. So that one's done. Can't be factored anymore, but we can factor the right one. So again, it factors into a plus and a minus. So what would go into my 2 parentheses? Perfect. 2x plus 3 and 2x minus 3. Because this breaks down into 2x and 2x, and 9 breaks down into 3 times 3. And then we still need that same 4x squared plus 9 as a factor also, because that can't be broken down anymore. So this would be our final answer. Any questions here? All right, let's look at B. How can I factor B? I can take out a greatest common factor. What would my greatest common factor be? Awesome. All of these numbers have a 3 in common that can divide out, and all of the variables have at least 2 p's that I can take away. So 3p squared is going to come out. What am I left with when I take out a 3p squared? P to the 6th power, because I have 8 p's here. When I divide the p's, I'm taking 2 away, so that would be p to the 6th power, plus 5p cubed, plus 6. Now this is kind of similar to the extra practice one that we did first. Let's see if I can factor this. Do I have 2 factors of 6 that add to 5? 3 and 2. 6 and negative 1 doesn't work because that would multiply and give us negative 6. So 3 and 2. What do you think is going to go into my parentheses? Awesome. P cubed plus 3 and p cubed plus 2. Because this p to the 6th power breaks down into p cubed and p cubed. Our goal is if we FOILed this back out, we would get the original. So somehow we need 6 p's in here. So we just split it up evenly. And then I can't forget the GCF that I took out in the beginning, so that 3p squared needs to go on the outside too. So this would be my final answer. Can I factor any one of these out anymore? No. Always check if you have something cubed, are both of these numbers perfect cubes? 3 is not a perfect cube and 2 is not a perfect cube, so we can't factor it anymore. So we would be done here. So remember our perfect cubes from yesterday. If I had 1 cubed, that would give me 1. So 1 is a perfect cube. If I had 2 cubed, that would be 8. So 8 would be a perfect cube. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. So these are examples of perfect cubes. So if I had something like p cubed plus 27, this is the sum of cubes. This we would have to use the formula. But in this example, we had 3 and 2, which neither one of those are perfect cubes, so it can't be factored anymore. Let's do number 5. I know some of you guys did this yesterday on your own, but just to practice, let's factor number 5. What would I do first for number 5? Take out a GCF. What's the GCF? 6z squared. So I'm going to divide out a 6z squared. So 6z squared goes to the outside. What am I left with? Z cubed minus 125. Now what's special about both z cubed and 125? They're both perfect cubes, so we know we're going to have to use our difference of cubes formula because we are subtracting. So the difference of cubes formula goes a minus b times a squared plus ab plus b squared. Now, if a cubed is z cubed, what is just a? Z. Perfect. If b cubed is 125, what is just b? 5. Awesome, because 5 cubed would give us 125. So now once we find our a and b, we're going to plug it into the formula. So outside, I still have that GCF that I took out in the beginning. It just stays outside. What would a minus b be? What goes in my first parentheses? Z minus 5. Perfect. We just take our a and b and subtract them there. So z minus 5. What would come next? Z squared or 5z, we would say,
Plus 5 squared.
plus 5 squared, which, what's 5 squared? 25. Awesome. So this would be our answer. All right, next thing we're going to look at is the factor theorem. So this is actually different than what we've been doing. We've been factoring. For the next two examples, we're determining if what they give us is a factor of the polynomial. So they'll give us a factor, and we have to figure out if it's a factor or not. So we have to test it. So to test and see if it's a factor, it would be a factor if and only if the remainder is 0. So we are going to be using synthetic division. So for example A, I have to determine if x minus 2 is a factor of this polynomial. So I'm going to draw my box. What's going to go inside my box? 1, 2, and negative 4. Just our coefficients here. So the coefficients of my polynomial go inside the box. What's going to go outside the box? Positive 2. Awesome, because we changed the sign. If it said x is equal to 2, that would be when you don't change the sign. So when it's x minus or x plus, you change the sign. So what's the first step I have to do for synthetic division? Drop down the 1, and then multiply. Then we add, then multiply, then add. We would get 4. Which number here is our remainder?
The last one.
The last one. Is my remainder 0?
No.
No. So that means that x minus 2 is not a factor. Because the remainder is not 0.
So that's the answer.
So that's the answer. All right, so let's look at B. So for B, we're trying to see if x plus 5 is a factor of this polynomial. What's going to go inside the box?
3, 15, negative 1, 0, 25.
Awesome. Got to check to see if we're missing a term. What term am I missing? X. So I got to put a 0 in that spot. So I have 3, 15, negative 1, 0, and 25. Perfect. If you forget the 0, your answer will be wrong. So don't forget about the 0. What number is going to go outside the box? Negative 5. Perfect, because it's an x plus 5, but we have to change the sign. So negative 5 goes on the outside. What's the first thing I have to do? Drop down the 3. And then on the outside, what do I do? Multiply. Inside, add. 15 minus 15 would be 0. What's 0 times negative 5? 0. Negative 1 plus 0? Negative 1 times 5? Positive 5, yep. And then 0 plus 5? Negative 5 times 5? Negative 25 plus 25? 0. So we get a remainder of 0. So what does that mean about x plus 5? If our remainder is 0, x plus 5 is a factor. So when your remainder is 0, whatever it gave you to divide, that would be a factor. So example 6 is the same. We have to show that what it gives us is a factor and then finish factoring it. So it's just like one step more. We just have to prove that x plus 3 is a factor and then continue to factor it. So same thing I just did, synthetic division. What's going to go inside the box? Awesome. Got to make sure that we put that 0 in the x squared spot. So it'd be 1, 3, 0, negative 1, negative 3. What's going to go outside the box? -3, perfect, because we changed the sign. So we drop down the 1. On the outside, multiply, so we get -3. -3 plus 3? 0. 0 times -3? 0 plus 0? -3 times 0? -1 plus 0? And -3 times -1? And -3 plus 3? 0. So we get 0 as the remainder. So is x plus 3 a factor? Yes. So x plus 3 is a factor. But we have to continue factoring this. So if my question started with x to the 4th power, what does my answer have to start with? X to the 3rd power. So this would be x squared plus x minus 1, remainder 0. So how would I write this polynomial? To simplify it, how would I write? What is it? X cubed minus 1. Perfect. We don't put the 0 x's in there. So it's just x cubed minus 1. Sure. Now we have to factor this. What's special about x cubed and -1 or 1? They're both perfect cubes. So this would be the difference of cubes, which is that formula that we have to remember. So the difference of cubes formula is a minus b times a squared plus ab plus b squared. So if a cubed is x cubed, what is just a? X. If b cubed is 1, what is just b? 1. So let's plug everything into our formula. What would go into the first parentheses? X minus 1. What would come next? Awesome. Plus x, because 1x would just be x. And then plus b squared, or 1 squared, would be 1. So this would be the rest of the factored part. I'm going to include the first factor that it gave me, so that x plus 3. Because that is also a factor. So this would be our question completely factored out. So that would be our answer.